We are finishing the lab. That was, yeah, okay. So anyway, so we talked about how the very first experiment, we used 2 milliliters of HCl and 3 milliliters of the thiocyanate ion. And again, the reason the concentration of the thiocyanate ion is the same as the sodium thiocyanate, it's 1 to 1 to 1. Cool? All right. And we use 6 molar HCl. Now to determine what the actual concentration of each thing was, we need to divide how many moles we had by the volume, which is where this comes in. So when you multiply the molarity of something by the volume you used, that's going to give you moles, because molarity has what unit? Moles over liters. Okay, so molarity is moles over liters, and volume has what unit? Liters. So when you multiply molarity by volume, you get moles. And then what we need to do is say, all right, based on the number of moles and the volume I have, what's my molarity of my new solution? And this is going to be molarity 2 multiplied by whatever the new volume is, volume 2. Okay. Now I added a term there that isn't in your on your lab. They just got rid of this moles equal section, but this is important, critically important, that you know that molarity times volume equals moles. What we really care about is how many moles of our ion did we use in the volume of the total solution. So we tend to just say M1V1 equals M2V2, but not putting the moles in there, yeah, that might get us tripped up. Because that's what it means. It means we want to know how many moles of our ion we have in the volume, so we can do our dilution equation, and there we go. So it's important you understand this. You understand this idea. Okay, it's not on the lab, because in the lab they got rid of this section right here, but it's important you realize that molarity times volume is moles. Give me a thumbs up, that makes sense. All right, so let's do our first one. In the first experiment, we want to know what our HCl concentration was, and we want to know what our S2O3 thiosulfate concentration was. So, M1V1 equals M2V2. You used 2 milliliters. I need to get more pillars. You used 2 milliliters of HCl. So this volume is going to be 0.002. And your concentration of your HCl was 6.0 molar. And the new volume that you had, all of your volumes should have been how much? Yeah, should have been 5 milliliters, so 0.005 liters. So this is liters. So you should have 0.005 liters in every run. Regardless of the combinations you used, the total volume should have been 5 milliliters in the glass vial. And then we can just solve for M2. This is, by the way, 0.012 moles of H plus ion. That look right? Cameron.
Why is it H plus ion? Because you're splitting.
Just because I know that the chlorine doesn't play a part. So it was 0.012 moles of HCl, but I know that the chlorine doesn't actually play a part in the reaction. It's the proton or the hydronium ion that plays a part. Joe.
Can you just refresh how you got those numbers?
Sure. Okay, so this is the concentration of my stock solution at 6 moles. 6 moles. Yeah. And the volume I used was 2 milliliters, which is 0.002 liters. So this is basically what I used. This is my target. So 6 moles, 0.002 liters, and then I need to know what my concentration is when this was diluted to 5 milliliters.
Okay.
Does that answer your question?
So are we just doing the same thing as the experiment that we did on Friday, just in math terms?
So on Friday we did the drops.
Yeah.
So this many milliliters of acid, this many milliliters of thiosulfate. Now you're determining what the actual concentration was. Because when you put 2 milliliters into 5 milliliters of solution, the concentration of the acid dropped. And when you put 3 milliliters into 5 milliliters of the concentration of the thiosulfate dropped. So we want to know what the actual concentrations are, because that's what's going to be useful in our data table. This gets a lot of people. Realize, again, there's going to be 1 or 2 lab questions of the 5 next spring you take. There's 5 of them are going to be your free response. 2 of them are going to be lab questions, maybe 1, probably 2. And they do this a lot. They're like, what is the concentration of this? And you're like, well, it's 6 molar. No, it's not, because the 6 molar got diluted into a new solution. So it's not 6 molar anymore, it's less. And your thiosulfate is not 0.15 molar anymore, it's less, because that 3 milliliters got diluted into 5 milliliters. Does that make sense? Mm-hmm. Now, I shielded you from this math last year. I just basically said, the concentration is this. The concentration is this. And I did all the solutions ahead of time. But now, at the AP level, you need to realize that when you take 2 things and put them together and they're both aqueous, that's going to dilute both of them. Mm-hmm. Cool? Cool. All right. So, based on this, experiment 1 had a concentration of what? For HCl? 2.4. 2.4? So it had a 2.4 molar concentration. And can you do the same thing with the thiosulfate, realizing that you use 0.15 molar and 0.003 liters? Taylor.
Could I get a lab paper?
I hope so. I don't know what happened to yours. I set them aside for you and Angelina. I was kind of hoping that somebody had picked them up and given them to you. So they're not there. And they're not in here. They end up over here. Nope. Okay, I'm going to print some up because I set them aside for you because we had extras. But then they just disappeared. Okay. They probably fell on the floor of the gen or chucked them. So yeah, I'll print them up for you right now. Okay. Oh, in fact, yours are going to have the updated numbers with the typos missing. You don't get the typo version. Angelina, I'm assuming you need it too?
Only for HCl, for the S2 negative thing, it's
Go. All right, so what's the concentration of the thiosulfate ion in the first experiment? 0.0990?
0.09.
So 0.090?
Yeah. Yeah.
Okay. Molar. All right, cool. So yeah, let's go ahead and just use our 2 significant digits. So is this something that you can do for all 6 experiments?
Yeah. Sure.
All right. So do this for all 6 experiments, and then let's take 10 minutes, I guess, and we'll come back together, and then we'll process the data with the tools that we have in front of us, and we'll determine the rate orders of the experiment. So try your best to finish as much of the lab as you can. I realize the last question is probably going to be tricky, but that's okay. We're going to do it together. Any questions?
Should we go to our lab groups?
Yes. Yeah. Work together in your lab groups. All right. Cool. So go ahead and do that, and we'll come back together in just a little bit.